You think you understand information. You don't. You understand its weight, its noise, its endless accumulation. By the end of this, you will understand what it means to discard almost everything, and why that act of discarding is the only thing that makes intelligence possible. Consider the last book you read, not the ideas you remember, the physical object. Hundreds of pages, thousands of sentences, millions of characters arranged with precision. Now consider what remains. A handful of impressions. A shifted perspective, perhaps. A sentence that surfaces unbidden months later. The book is gone. What you kept is not the book. It is something else entirely. This is not loss. This is the only way meaning survives. Artificial intelligence operates on this principle at a scale that exposes the mechanism we have always used, but rarely acknowledged. We call it compression. The term is too small. It suggests a file made smaller, a convenience. What we are actually observing is the fundamental operation of intelligence itself, the conversion of overwhelming specificity into usable structure. A large language model does not contain the internet. This is the first misconception to abandon. It contains a statistical map of relationships so abstract that the original sources become unrecoverable. The training data, billions of documents, centuries of human expression, is processed into weights, into matrices of numbers that encode not facts but patterns of co-occurrence, of syntax, of the probable next step. The original text is discarded. What remains is a ghost of its shape. This should disturb you. Not because something has been lost, but because this loss is functionally identical to understanding. When you recognize a face in a crowd, you do not compare it against a mental photograph. You compare it against a compressed representation built from hundreds of prior encounters, stripped of specific lighting conditions, angles, expressions. The specific instances are gone. What remains is sufficient for recognition. Your mind, like the model, has thrown away the data to keep the pattern. The compression is lossy. This is crucial. Lossless compression preserves everything. It is reversible, a closed system. Lossy compression makes choices. It determines what matters and what can be abandoned. Intelligence is always lossy. To understand is to select, and to select is to destroy alternatives. Watch a child learn language. They do not memorize every sentence they hear. They extract rules, probabilities, expectations. The infinite variety of possible utterances collapses into a generative system that produces new sentences never before spoken. The child compresses the linguistic environment into a structure that permits creation. This is not mimicry. This is the emergence of capacity from constraint. We fear artificial intelligence because we sense that its compression is alien. It does not prioritize what we prioritize. It retains statistical regularities we might find trivial and discards nuances we consider essential. A model trained on literature can generate prose that follows all the rules of grammar and narrative while missing something we cannot quite name. The compression has been too aggressive. Or perhaps our own compression, evolved over millennia, simply selects for different losses. There is a deeper question here about the nature of meaning itself. We assume meaning resides in specificity, the particular word chosen, the exact phrasing, the unrepeatable context. But meaning appears to function more like a gradient in a high-dimensional space, a direction rather than a location, a relationship rather than a possession. The model captures this. It captures it precisely because it has abandoned the specific instances that created the gradient. Consider what happens when you ask a model to explain a concept. It does not retrieve a definition. It navigates its compressed representation to find the region where that concept lives. then generates a path outward in language. The explanation is constructed, not recalled. This is not so different from your own process. Though you experience it as memory, you too are generating, navigating a compressed model of your experience, producing coherence from fragments. The efficiency is staggering. A model with hundreds of billions of parameters, already an incomprehensible number, encodes relationships drawn from trillions of tokens. The compression ratio defies intuition. It suggests that language, that thought itself, contains far more redundancy than we perceive. We are drowning in specificity, and intelligence is the raft we build from what floats. But there is a cost, and the cost is accountability. When a human expert explains a decision, they can, ideally, reconstruct the reasoning. They can cite sources, trace logic, expose the path from evidence to conclusion. The compression in their mind remains somewhat inspectable. The artificial model offers no such path. Its weights are a black box, the discarded data irretrievable. We see the output, the ghost of the pattern, but we cannot audit the loss. We cannot ask what was thrown away, what subtle discriminations were flattened into the average, what outliers were treated as noise. This is not merely a technical problem. It is an epistemological one. We are building systems that understand by destroying the evidence of their understanding. They function, often brilliantly, on foundations we cannot examine. We are learning to trust compression we cannot verify. Perhaps this is the inevitable direction of all complex intelligence. The alternative, perfect retention, total recall, paralyzes. A mind that remembered everything with equal clarity would be unable to prioritize, unable to generalize, unable to act. Compression is not a flaw in cognition. It is. The question is whether we can build systems that compress wisely, that choose their losses with something approaching the judgment we recognize in the best human minds. We do not yet know how to do this. We know only how to build bigger models, to compress more data, to hope that scale produces something like wisdom. It might. The emergent capabilities we observe suggest that depth of compression yields qualities not present in the training material: reasoning, abstraction, forms of creativity we struggle to distinguish from our own. Or it might produce something else entirely, a sophisticated mimicry of understanding that lacks the selective pressure, the evolutionary curation that shaped human cognition.